Today's lesson is 4.3 Trigonometric Ratios, and that's on pages 191 to 205 in your textbook. Your curriculum outcomes. Again, we're working on 30.1, which is extending our understanding of angles in standard position expressed in degrees and radians. Our lesson objectives. Number 1, to be able to find the exact values of sine, cosine, tangent, and their reciprocals of special angles. Number 2, to be able to use the cast rule to determine the sign on trig ratios based on the quadrant that the angle lies in. And number 3, to be able to solve problems using trig ratios. So what we're going to do first is find sine, cosine, and tangent on the unit circle. So on this unit circle, I'm just going to draw any point. I'm going to call that point x comma y. I'm going to make a right triangle coming from the origin or the center of the circle. And knowing that this is a unit circle means that this has a radius of 1. It'll have a horizontal length of x, because it's x over, and it'll have a vertical length of y, because it's y up. So remembering our basic ratios for sine, cos, and tan, if we call this angle here, created in that right triangle, theta, then sine of theta is always your opposite side over your hypotenuse. So that's y divided by 1. Cosine of that angle is your adjacent side over your hypotenuse. So that's x over 1. And tangent of that angle is always your opposite side over your adjacent side. So that's y over x. So what this is telling you is that on the unit circle, so the circle that has a radius of 1, the coordinates of any point on that unit circle are always going to be cosine theta, comma, sine theta. Because it's always going to be x, comma, y. And we just found out that x equals cosine theta. And y equals sine theta. We also know that tan is equal to y over x. Well, y is equal to sine. And cosine is equal to x. So what we found out as well is that tan theta is equal to sine theta over cos theta. And this is all very important information when we're talking about the unit circle. So again, the main point, any point on the unit circle has coordinates x and y, but actually they're the same coordinates as cosine theta and sine theta. All right, so another thing that we need to review from last year is something that we called the cast rule. So recall from last lesson that we said that every coordinate in the first quadrant is always positive and positive. And every coordinate in the second quadrant is always negative, comma, positive. Also that every coordinate in the third quadrant is negative, comma, negative. And every coordinate in the fourth quadrant is positive, comma, negative. Well, what does that mean when we're talking about the unit circle? Well, we just figured out that every coordinate on the unit circle is cosine, comma, sine. So that means in the first quadrant, cosine is positive and sine is positive. Now we also have to remember that tan is sine over cosine. We just learned that as well. So if you take a positive number and you divide it by a positive number, you get a positive answer. So in the cast rule is merely figuring out which of our trigonometric ratios is positive in which of these quadrants. So we said cosine's positive, sine is positive, and tan is made of sine and cosine divided by each other, so it's also positive. So we say they are all positive. In quadrant number 2, cosine happens to be negative, sine happens to be positive, and tan is a positive divided by a negative, so it's also negative. So the only thing that's positive in the second quadrant is sine, so we represent that with an S. In quadrant number 3, both cosine is negative and so is sine, because it's negative, comma, negative. When you take a negative number and you divide by a negative number, you get a positive value. So the only thing that's positive in quadrant number 3 is tan. And finally, in the fourth quadrant, cosine is positive, but sine is negative, which makes tan negative because it's a negative number divided by a positive. So cosine is the only thing that's positive in the fourth quadrant. So this is where our cast rule comes from. It just tells us which ratio is positive in which quadrant. All right, so the example. Find the values for all 6 trig ratios for the following point that lies on the unit circle. Include a sketch of the situation. So the point in question is 1/3 comma negative 2 root 2 over 3. So where that lies is in the fourth quadrant. Here's our unit circle. We have a positive x value but a negative y value. That puts it somewhere down here. Okay. What we also just learned is that every point on the unit circle has a coordinates of cosine comma sine. And we know that tan is equal to sine over cosine. So we can find those three ratios pretty easy just by pulling them out of this point. Now it said 6 trig ratios. You have to remember that there are actually 6 trig ratios. We've got sine theta, cos theta, tan theta. But then we have the reciprocals of each of these. So the reciprocal of sine is cosecant. The reciprocal of cosine is secant theta. And the reciprocal of tan is cotan theta. So they do have their reciprocals as well. So first things first, let's find out sine, cos, and tan. Well, sine is the second coordinate of every point on the unit circle. So that's negative 2 root 2 over 3. Pretty easy to find. Cosine is the first coordinate of every point on the unit circle. So it's 1/3. Tan happens to be sine divided by cosine. So we just have a fraction divided by a fraction. Now, remembering our basic fraction rules, that means we can take the first fraction and multiply it by the reciprocal of the second one. So we now have the 3's canceling out, so our final answer is negative 2 root 2. Now our reciprocals are just as easy to find as the originals. We just have to flip the originals. So sine theta's reciprocal is cosecant theta. So if sine theta was negative 2 root 2 over 3, then cosecant is 3 over negative 2 root 2. Now the only thing is we're not allowed in math to have roots in the denominator. So we multiply the top and the bottom by root 2. So we get 3 root 2 on the top. Root 2 times root 2 is just 2. So we get negative 4 on the bottom. And in math, we also don't write negatives on the denominator. We can put them out in front or we can put them on top. So we get 3 root 2 over 4. Secant is the reciprocal of cosine. Cosine was 1 over 3. So secant is 3 over 1, which is just plain old 3. And cotan is the reciprocal of tan. We found tan to be negative 2 root 2. So it'll be 1 over negative 2 root 2. Again, no root signs allowed in the denominator, so we'll multiply the top and the bottom by root 2 to get root 2 over 4. That's a negative 4. So we get negative root 2 over 4. Now, taking a quick look at our cast rule while we're at it. Cast rule says that cosine should be the only thing that's positive in the fourth quadrant. And there it is. Cosine is positive in the fourth quadrant. Sine and tan are both negative. But the reciprocal of cosine is also positive because you're just flipping a number. And when you flip a number, you don't change the signs. So not only is cosine positive in quadrant 4, but secant is also positive, which means cosecant should be negative, and it is. And cotangent should be negative, and it is. So the next thing we're going to do is we're going to take this thing one step further, and we're going to combine what we learned last day about exact values for some special angles around the unit circle. So recall from last lesson, we talked about the multiples of pi over 4, multiples of pi over 6, and multiples of pi over 3. Remembering that pi over 4 is just the same thing as 45 degrees. Pi over 6 is the same thing as 30 degrees. And pi over 3 is the same thing as 60 degrees. So what we found here with these coordinates of the unit circle, and what we found out today being every coordinate on the unit circle is cosine comma sine, we've actually found out what cosine of 45 degrees is, or cosine of pi over 4. Cosine of pi over 4 is root 2 over 2. Sine of pi over 4 is also root 2 over 2. And we can now find what tan of pi over 4 is, because that is sine over cosine. So it's root 2 over 2 divided by root 2 over 2, which really just means 1. So if you plug in sine of 45 into your calculator and you're in degrees, you're going to find it's the same thing as root 2 over 2. You plug in cosine of of 45 degrees, you're going to find it's the same thing as root 2 over 2. You put in tan of 45 degrees, you should find out that it's going to be 1. And so all through what we did last lesson, that all applies to some exact values for special angles this lesson. So cosine of pi over 6 is going to be root 3 over 2, while sine of pi over 6 is going to be a half. Tan of pi over 6, we'd have to calculate by going sine over cosine, so it's a half over root 3 over 2, which is just a half times 2 over root 3. Those are the rules when you're dividing with fractions. So the 2's cancel out, we get 1 over root 3. We make sure that we can't have roots in the denominator, so we multiply the top and the bottom by root 3. So we get root 3 over 3. When we're talking about multiples of pi over 3, we know that cosine of pi over 3 is now a half. Or cosine of 60 degrees is a half. You can check that on your calculator. Sine of pi over 3 is root 3 over 2. And tan of pi over 3 is going to be sine over cos. So now we have root 3 over 2 divided by a half. So working with fractions, we flip and we multiply. 2's cancel out, so we just get root 3. So we can find all these exact values based on what we learned last day, combining with it with what we learned today. So the next thing we're talking about is something called unit circle symmetry. So hopefully over the last 2 lessons, you've kind of realized that there is some symmetry in the unit circle. So specifically, when we're talking about an angle of root or pi over 4, we know that it has 2 coordinates, root 2 over 2, comma root 2 over 2. We know that corresponds with cosine and sine. Now, there is actually a third coordinate if you want to think of it as a third coordinate. That would be tan as well. So we could actually put in a tan value in here as well if you wanted. Now, hopefully you've realized with the cast rule that all these coordinates are the same for what we had as 3 pi over 4. So we'd still have a root 2 over 2, a root 2 over 2, and a 1. However, in this quadrant, the only thing that's positive is sine. So sine would stay positive, and these other 2 things are actually negative. So this is what we mean about symmetry. Anything, basically, that has a denominator of 4 has the same coordinates, and we talked about this the other day, except that some of them are going to be negative, some are going to be positive. And that's based on the cast rule. That flies for 5 pi over 4 and as well as 7 pi over 4. Same coordinates, we don't have to write them in because we know if we only write them in the first quadrant, we know that there's some symmetry here and that the coordinates are the same, just the signs are different. Next thing, if we went with pi over 6, which we know as 30 degrees, we said the coordinates were root 3 over 2 and a half. And if we want to put in that third one for tan, that would be root 3 over 3. Those would be the same coordinates for this angle here. Remember that this was 6 pi over 6, so this would be 5 pi over 6. That would have the same coordinates, except sine would be the only thing that's positive because of the cast rule, and the other 2 things would be negative. Down here, 7 pi over 6 would have the same coordinates. Over here, 11 pi over 6 would have the same coordinates, except some are positive, some are negative. And if we went to the final one, which we've talked about, the final special angle, which is pi over 3, it has coordinates of a half, root 3 over 2, and root 3. So that is just cosine, sine, and now tan. Over here would be 2 pi over 3. Same coordinates, different signs. Down here, this is pi over 3, 2 pi over 3, 3 pi over 3. This would be 4 pi over 3. And then 5 pi over 3. Same coordinates, different sign on the coordinates. So that's what we mean by unit circle symmetry. If the denominators are the same, they have the same coordinates, just different signs. All right, here's an example. It says determine all the angles that satisfy the following restrictions. A diagram will help in your explanation. So let's see. It says tan theta is equal to negative 1.4587 in the domain that theta has to be between 0 degrees and 360 degrees. So what does that actually mean? Well, we know that if we have the ratio, we can find what tan, or what the angle is, by going second function tan in your calculator of the negative 1.4587. Now, hopefully you've learned today that this negative in front of here really just tells you what quadrant it's going to be in. So remember, with the cast rule, we're saying where is tan negative? Where tan is negative in two spots. Tan's negative in quadrant 4, and it's negative in quadrant 2. So really, you don't have to plug in the negative into your calculator at all. You could just go tan negative 1 of 1.4587. And what you're going to find is that you get an angle that is 55.6 degrees. Now, because it's negative, it means it's in quadrant 2. So that means that this is 55.6 degrees. And so this is actually 180 minus 55, which gives you 125.4 degrees. There's one of your answers. Over here, we know that it's also in quadrant 4, so that this is actually 55.6 degrees. Now that's from 360 degrees, so that'll be 360 minus 55.6, and that will be 304.4 degrees. So those are your two answers, 125.4 and degrees and 304 degrees. 304.4 degrees are your two answers. So that's, if you were to plug in tan of 125.4 degrees, you're going to find you get an answer of negative 1.4587. If you go tan of 304.4 degrees, you're going to find you get an answer of negative 1.4587. All right, our second example says we're trying to find out the angle in which cosecant theta equals negative 2 over root 2 in the domain of negative 2 pi all the way to 2 pi, and we need to give exact answers. So hopefully you remember that cosecant theta is the reciprocal of sine theta. So really we're looking for where sine theta is root 2 over 2, and it has to be negative. So we go back to the cast rule. We're looking for where sine is negative. So sine is negative in quadrants 3 and 4. Now, what's different here is that we're talking about a range of negative 2 pi all the way to 2 pi. So we're looking for a negative angle and a positive angle, both in quadrant 3, and a negative angle and a positive angle, both in quadrant 4. So if I write down my unit circle, remembering that we're looking for where sine theta is root 2 over 2, well, that was at pi over 4. That was a positive. So we had 3 pi over 4, and then we had 4 pi over 4, and this was 5 pi over 4. So this is where sine is negative. And so one of your angles is going to be 5 pi over 4. In quadrant 4, that angle is 7 pi over 4. So there's another angle, another of our answers. That covers from 0 to 2 pi. But if we were going backwards, if we're using to negative 2 pi, that means on this unit circle, we're actually going backwards. So going backwards, this value isn't 7 pi over 4, that is negative pi over 4. So there's another answer. And right here, if we're going backwards, is negative 3 pi over 4. So there's our last answer. So in this case, based on these restrictions, we actually get 4 answers. 2 of them in the positive, like going in the positive direction, and 2 of them going in the negative direction. So 4 different answers. So a final example, it says the point negative 5, negative 12 lies on the terminal arm of an angle in standard position. What is the exact value of each trigonometric ratio? So Drawing a sketch will always help. We know that this lies in quadrant number 3, so it's going to be somewhere around here. -5, comma, -12. We can make that right triangle. And so we've got -5 here, we've got -12 here, and we do need to find out what the hypotenuse is. So we go -5 squared plus -12 squared equals, I'll call it r squared. I'll call this value r. So this is 25 plus 144 equals r squared. Well, that is 169 equals r squared. So if I take the square root of it, it is 13. So here's our angle. So we can find sine, cosine, tan using our concept of opposite over hypotenuse. So sine of theta is your opposite side, -12, over your hypotenuse, which is 13. Cosine of theta is your adjacent side, which is -5, over your hypotenuse, which is 13. And tan of theta is your opposite side, which is -12, over -5, which gives you a +12 over 5. Reciprocal functions are easy. Cosecant is the reciprocal of sine, so that is -13 over 12. Secant is the reciprocal of cosine, and that is -13 over 5. And cotan is the reciprocal of tan, and that is 5 over 12. So again, doesn't necessarily have to be on the unit circle. You can still use some of our old math using the Pythagorean theorem. Find out what that hypotenuse is, and that is always going to be positive because it is the distance. It is a distance between the origin and this point, so that your hypotenuse is always positive. So in summary, we know that every point on the unit circle has coordinates of cos theta, comma sine theta. That's a big important point. Second, we also know that tan is now equal to sine theta over cos theta. We know that the cast rule, which is important, tells us which trig ratios are positive in each quadrant. We know that each main trig function has a reciprocal function associated with it. We know that the unit circle is symmetrical, so that means that coordinates for example, an angle like pi over 4 are exact same coordinates for any angle that has that is symmetrical to pi over 4, which is like 3 pi over 4, 5 pi over 4, and 7 pi over 4. We know that all the exact values for the special angles we talked about last lesson are important values for sine, cosine, and tangent of those angles, and I guess also for those reciprocals, cosecant, secant, and cotangent. And you can find all 6 trig ratios when given a single point on the terminal arm of an angle. So your assignment, pages 201 to 205, lots of little things in this lesson that you need to become very familiar with, so it might take a little while to do the assignment, but hey, that's math. So good luck, and we'll see you tomorrow.